We have with us Mike Roberts. He runs San Diego Code School, and he's going to talk about his program and also what it's like to be a software developer and touch a little bit on tech careers in the short time that we have today. So Mike, if you'd like to kind of go over the basics of what your program is about, I think we have students here quite interested.
Sure. So I'll start with just a little brief bio. My background is that I started sort of playing around as a hobby with computers when I was about your age, so about 12 or 13. So I've been writing software now for 32 years. I spend a lot of that time getting an opportunity to work at some pretty amazing companies. And so they may not be brands and names that you're aware of, but I can kind of describe what the lifestyle is like. And that is a day in the life of a software engineer is one where we usually came into the office around 9. So normally, we have what I call banker hours, like 9 to 5. We had catered breakfast and lunch every day. So I got the two free meals every day. If you came in early in the morning, you get bacon. If you came in a little late, bacon's probably gone. So they try to get us in there early by giving us a little bit of the good stuff. We had, pretty open office. So the floor plan in many tech offices is kind of open. So you're in a space with lots of other people. So a lot of times people wear headphones most of the day. So they kind of have a little bit of focus and ability to concentrate. The daily routine was usually to meet with the whole team. We do what's called a stand up in the morning. That means that everybody kind of goes around and shares what they worked on yesterday, where they're working on today, and anything that is blocking their progress as a team. And then you kind of settle in. Oftentimes I might spend a little bit of my morning, reading technical blogs and learning a little bit. So one of the things about software engineering is you always have to be learning. It's a constant environment where things are changing. And so it's really neat that you do get to really explore and solve interesting challenges every day. Every day is something different and new, and you're not doing a lot of the same repetitive tasks day after day. And then I'd spend a lot of time looking at other people's code and ensuring that it was of high quality. We call those code reviews. So I'd be reviewing other people's code. I'd be writing some of my own software, and I might be working on a website, or I might be working to fix some backend service. Again, reading and writing things that will solve problems for the business. We'd have lunch. We had sort of a work hard, play hard atmosphere. So we had like a ping pong table in our lobby area, and we had like darts and foosball, and we didn't have water cannons, but we had like those little Nerf guns. And so it would be not uncommon to have, a little Nerf gun fight break out in a day. We had dogs running around in the office. We had lots of perks like massages, haircuts, taxes done, and laundry service. So they did a really good job of like spoiling us to make sure that we felt like this was the right company, and we didn't want to get, they didn't want us to get poached to go work somewhere else. So it's a very in-demand field. Obviously, it's compensated really well. So made a 6-figure income for most of my career as a software engineer. So that said, it is tremendously difficult for some folks to get into the space. There's sort of 2 routes, well, maybe 3. So there's the route of being self-taught. That's how I learned. So I initially taught myself, and just for a long time, I wasn't a great student. So, I'm usually the first to admit that college isn't for everybody. My parents were both school teachers, and they both really encouraged and wanted me, and were very disappointed that I was on the 10-year plan at San Diego State University. But I did eventually get a degree. But I was fortunate in that I knew what I was interested in early on, and I basically worked really hard at it as a hobby until I could make it something that I could do. And then later the degree came, but I was already kind of, off to the races and very interested in it. So that's the first route. You could be a self-taught developer, and you could do it as a hobby, and you could really make it a passion as well as something that you could do as a job. The second route I think a lot of people go through is a very traditional: graduate from high school, then go to either community college or go to a 4-year school and get a CS degree, computer science degree. So that's an engineering degree. So it does require quite a bit of study of like the theory and the mathematics involved. And so it's tough. The standard is pretty high, but those are where you can get very quickly into some of the very prestigious jobs. So not only places that have all the benefits that I talked about, but at organizations like Facebook, Netflix, Google, Microsoft, they recruit heavily out of 4-year college degree programs. So if you're really interested in the high end, highfalutin fancy jobs in like New York or San Francisco, then that's the route that a lot of people go through. And then the last is the route of going through a boot camp or an apprenticeship program, some other alternative path to training that's usually a much shorter timeline, and it usually can produce pretty significant results with not the same kind of overhead. So I happen to run one of those. I happen to run a program that is now a registered apprenticeship program here in the state of California. And pretty soon we'll be a federally, so Department of Labor approved program. So if anybody's heard of the apprenticeships, typically you think of more traditional trade and union type work. So you might hear of like plumbers or welders or electricians going through this pay while you learn training program where you go through some sort of classroom experience, and then you spend a good amount of time working alongside a master, so a master craftsperson, and that person then sort of shares with you what it's like to be trained on the job. And so big plus to that is you get to earn some wages, and you get to be sort of like independent while you're going through the process of upskilling. So our program is now a registered apprenticeship program. It used to be a tuition-based program. So we found that a lot of our students either couldn't afford the tuition, it was really difficult, they were struggling, or they couldn't afford to like set aside 3 months of their life to basically not work and just focus on upskilling. So apprenticeship kind of combines the ability that you can earn a little bit of income while you're training and the rapid upskilling. So it's not a 4-year program. Instead, our program is a 1-year program. So you basically have a 1-year full-time job and you're learning to become a software engineer. So if we look at what typical apprentice, like the demographics look like, it's very diverse. So we pride ourselves on trying to create opportunities for people that are often underrepresented in software engineering. So in software engineering, it's largely male and white and Asian are sort of the demographics. There are not nearly as many women and Hispanic, Black, and folks that are immigrants, maybe first generation here in the United States. So our targeted population is really those individuals that are not heavily represented, because employers are really eager to find quality candidates that are maybe a little bit different. That's not to say that if you're a white cisgendered male that you're not going to be successful or you can't get into the program. Absolutely you can. So we're an equal opportunity employer, but our goal is really to get more people that look like me or maybe women involved in this growing field, because this is where a lot of the jobs of the future are. So what makes our program unique as compared to maybe like I said, a CS program is really the fact that you are able to kind of sustain yourself while you're going through the program by earning a wage, right? And so our candidates start at $18 per hour. So 18 is a little above what we consider to be like the minimum like living standard. And then you get a raise at 6 months in to $19 an hour. At the end of the first year, you're making $20 an hour, which is enough to kind of like sustain, a modest living here in San Diego County. So it is a 1-year program, so it's 2,000 hours of hands-on experience. And then our candidates actually get an opportunity to learn a lot of what it takes to really build software, and not as much of the theory is. So we go beyond just the theory and instead have them building things and working for clients on real world projects. So it's really like being on the job in an engineering shop. You're getting exactly the same level of experience that you would versus in a college program where you might study the theory and understand, okay, this is how it's done at a high level, but then you have to kind of train on your own when you first come into an organization and learn things like version control. How do we maintain the code in such a way where we can all work on it at the same time? So that's the system we use for that is called version control. So I can point to someone, they have actually a button called blame. You can blame someone when something breaks because we kept track of who made the changes, right? So the idea behind the real practical hands-on experiences, our candidates can ramp up faster when they come into an organization. And then finally, our candidates graduate debt-free. So we don't have our students take out loans. At this point, our apprenticeship program is 100% employee funded. It's funded by the projects that we work on. And so it really is a great like opportunity for folks that are not looking to take on a big student loan in order to get into a great opportunity. So oftentimes people will ask, like, well, what does it take then? Well, how do I qualify to be in this kind of a program? So the reality is we're just looking for people that are like good employees, folks that are going to work really hard, that are gritty. And we use something called learning agility, which is a fancy way of saying how fast can you learn, right? We all have a capacity to learn things. And a lot of people say, I pick things up quickly. That's kind of the attribute that we are hoping that we can identify in candidates. And if someone doesn't have a high learning agility, it is something that can be learned. So you think of, there's something called whether or not you have a growth mindset, whether or not you think that you can actually have this potential to get better, and that you don't have this like fixed human potential where you're only going to be this good because you're not super smart. Well, maybe not yet, but you can get better, right? You can get smarter. And so the idea is if you really have a growth mindset, if you have the ability to either learn quickly or start adapting and get better at learning, because again, that's going to be a lifelong skill in software engineering. That's what we identify and say, okay, that candidate is going to be really good. We got a lot of applications. We probably get about 150 applications for every like 5 positions that we have open. So we're only able to accept like 5 to 8% of the people that will apply for the program. And when we can identify that somebody has that capacity, those are people that we're interested in bringing in. And then it's not based on like, are you technically, like you have a high technical aptitude, right? Are you super good with computers? Are you great with math? All of those things are things that we think we can teach and people can learn easily. What we can't easily teach is being gritty, right? And getting after it and working hard. Those are things that are hard to teach. Those are attributes you either have or you need to go work on. And when I say you need to work on it, it's like something that you have to decide to make that like, internal switch flip and say, I'm going to be motivated. I'm going to get this done. We're okay with people that are justice involved. So folks that have had some kind of a criminal justice issue, that's not usually as big of a deal in the tech space. So not to say you should go out there and be bad, but if you happen to make a mistake, this is an industry where there's a lot more grace given, an opportunity for you to put your past behind you and move forward and have some great opportunities, even if you've had something in your past. And then because it is a job, right? This is full-time work. This is not a part-time program. This is a full-time immersive, like once you're in, you have a full-time job. And we expect you to put in not only that, but some additional time sort of at home, working through the things that are going to make you better as a software engineer. So constantly learning. So one more slide, and that is how do folks get started? So the careers that we train people for, so the different apprentices that we have, the apprenticeship roles are listed here. So the first is software engineers, and then we have software application developers. The difference between the two is the engineer, that role is more of like building systems that you might not see. They're kind of on the back end and they're behind the curtain, things that make the web work, things that make applications work. The software application developer is making more things that you actually like when you click on an app on your phone, things that you can usually feel and interact with, right? Then we have data engineers. So there's a ton of data that is always being collected when you're out on the internet, when you're playing games. And so there's a big need, a demand for people that can take that data and then can clean it and store it in such a way where they can later on use machine learning and AI, artificial intelligence, to make meaningful assumptions about the data and projections, et cetera, like using that data. So data engineers are required to like clean the data, store the data, make sure that it's preserved. And then we have agile project developers. Those are folks that help teams work efficiently and get a lot of things done, high volume of things done with low number of defects. And then finally, you've got QA automation. And their job is to find the defects before it gets to a customer, before it gets delivered to somebody. So their job is to sort of automate systems and testing and make sure that we're delivering quality products whenever we're delivering software. So I'm going to pause there with my slides and sort of open it up. Mr. Staubach, if you have questions or if anybody from the audience has questions, I'm more than happy to talk through anything, answer any questions I can.
Yeah, so if you got questions about tech careers in general or his program, go ahead and come off mic or just throw it in the chat, either one. Um, One of the questions I have, and this is really specific to high school students, is what was your advice right now? If you want it, let's say you're in 11th grade, or maybe you're a senior right now, what can you do while you're in high school to start building up the skills you need for this particular, to be a software developer? What would your advice be? You're like, yeah, I'm really interested in this. What are some steps you would go and take? Unfortunately, right now at Vista High School, we do not have a coding class and things like that. We do have a gaming class. We do not have a coding class. So what would be some advice you would give students, or high school students?
Sure.
Some things to look into or to practice with before they get into a formal program.
All right. So it's going to sound weird. I'm going to set it out there. Learn how to play chess. So we're actually starting a program here in San Diego, and it's a combination of chess, mathematics, and computer science. And they kind of build on each other. So if you learn something like chess, and the reason why I say chess, but it could be any other kind of like complex problem solving type game, then you begin to sort of create mental models in your brain for how you go about solving problems and create strategies that you can then rely on, coupled with fundamentals of math. So if you're not super solid on your math skills, you need to be at about algebra to algebra 2. You don't need to go all the way to like calculus for you to be super successful in software engineering, but you should try and get through, eventually be at the point where you can get through algebra 2, second part of algebra. And then the third part is just learning the fundamentals. And there's tons of places you can go online and just learn the basics about like what is programming. And you can start with something as simple as like Scratch online, which is made more for kids, but it's a great tool to learn just the principles of how do you think about breaking something into a step-by-step process that's repeatable and maintainable. So chess is a huge one though. So if you've never played chess, if you've never tried chess, that'd be something to really jump in and dive in and say, let me learn it, because there's a bunch of rules you got to learn. And then there's strategies and there's logic and there's decision making that will help prime you to have what I call, again, this mental model that you can, while you're learning computer science, refer back to your experience. Now, chess just is not your thing, right? Chess doesn't seem exciting for some folks. Then learn to play an instrument, because there's been some correlation they found between folks that play instruments and the way that kind of primes your brain and your thought process around mathematics for, again, later on using that for computer science. And then finally, there's a ton of resources online that you can use that are free, they cost nothing for you to start dabbling and trying out what it's like to like write some programs and programming. And then if you decide that you like it, then there's definitely the opportunity for you to just keep pursuing it and work on it as a hobby while you're going through high school. And then you can kind of, clarify, okay, is this something I want to go through a CS program for? Or is this something I want to try and do by self-teaching and then finding a job? So there's a lot of opportunities. That's the nice part. When I was young, when I was little, like computers were brand new and there was no coding boot camps. There were no apprenticeships. There really weren't a lot of college degree programs. A lot of people were not getting a degree in computer science. If you wanted to be a programmer, you kind of just learned on your own, and then you wrote programs and you tried to sell them to people, right? And then eventually you might be able to get a job working somewhere.
So kind of keying off of that a little bit, what would you suggest is maybe a couple of good languages to look into if I'm just starting out? What languages do you think I should start dabbling in and getting my feet wet in?
So I almost always suggest to folks that they start with web development, because it's so accessible and easy. If you have access even to just a Chromebook, right? So you don't have to have a full computer. If you just have a Chromebook, you have a full-fledged laptop, even better, or desktop, but you can open up the browser and you can actually start writing code inside of a browser, right? So you can immediately start to sort of manipulate web pages, and you can kind of change the web page and start just exploring and start sort of hacking at it until you get a good sense of like, oh, this is how this is working. And this is how these pieces sort of work together. So I would start with JavaScript as the language. There's also HTML and CSS as sort of the other components to web development. They're not strictly languages, but they're the other pieces that are used in order for you to really understand the basics of web development. From web development, I usually tell people kind of start there because it's the easiest for you to see, like, here's, I just did this and here's how it changes this. And you can test it very quickly and validate, like, okay, this is making sense. I'm starting to kind of understand how this is working. Then you can move on to something else that's a little bit more challenging, but has maybe some practical applications to it. Like, might be learning Python. It's fairly popular these days. That's an easy language, so it's often used as a training language or teaching language, but it has more practical applications in like data engineering and machine learning. But for a lot of folks, that's a high bar to go from, nothing at all to learning something like Python. So instead, I usually say start with web development, and then that can open up the opportunity for you to very quickly learn other languages, right? So rather than focusing on like, well, if I don't learn this one, is there some advantage to learning this other one? I don't usually recommend you trying to evaluate each one. I'd say instead, like, what would be most interesting to you? Would it be interesting to change some web pages or build some basic games? Awesome. JavaScript will do all those things for you. It's like the Swiss Army knife of languages. And then from there, if you said, yeah, that's exciting, but I really want to be able to do X, Y, or Z, then there are languages that kind of cater towards that, right? So if you want to, like, I want to make a game for my phone, still JavaScript, by the way. So game for your phone, JavaScript. You don't have to learn anything super fancy like Swift or Dart or Java or Kotlin or anything that you think, hey, I've seen this one thing one place. Instead, JavaScript is going to work in most of those places. And then if there's something very specific, you go to Python or Ruby or something else.
So I got a question for our crowd here, which is, if you have done any coding at all, I want to see a thumbs up. So go grab a thumbs up.
I want to see this too. I got to open up my own.
And let me see if anybody's done any coding at all. If you've dabbled in web development, if you've ever done a little Java. Kyle.
Nice.
Tell me, Kyle, what have you done?
I've used C#.
Can you repeat that for me?
Yeah, you broke up a little bit.
I was working with C#.
C#.
Oh, nice.
Okay.
Yeah.
All right. So everybody else here doesn't have any experience. They haven't done any coding or any web development.
So C#
thumbs up.
Yeah, C# is awesome. It's used in a lot of game development. So if you've heard of Unity, that's a free, by the way. You can download Unity. You can start playing around and making your own. Really, like these are the same pieces of software that are being used by like shops that make AAA games. So Unity is like the industry standard, one of the industry standard applications, and they use C# as the language that you write sort of all the code part in. But you can actually get a lot done in just Unity without having to write a lot of code. So if you're interested in games, C# and Unity, good route to go.
Yeah, and we do offer some minor Unity development in one of our more advanced gaming classes. So they make a little bit hands-on with that.
Yeah.
I think since we have a pretty inexperienced group here, maybe you could maybe bring up, I don't know if you have it ready, either maybe your Git repository or just an IDE, and maybe show them what the environment of programming looks like. So yeah, those who haven't been inside, maybe that's a good thing we can take a look at here for a few minutes.
All right, let me find my screen here. So
unlike most occupations, at least in software development, we can bring something up and kind of show you what the work environment looks like a little bit.
All right, hang on. Sorry, I hit the wrong share button. So share screen.
It's okay.
I don't think I can share my whole screen. Show all windows. All right, that's all right. I'll just open up this one here. Okay, can you see this tab or the screen?
Yeah, I see yeah, I can see that.
Okay, so GitHub is where we live. So when GitHub goes down, everybody's having a bad day. It's like a snow day at school, right? So GitHub is where we keep all of our code, and it's sort of like an industry standard. Pretty much everybody uses this as the place where they store everything. And Then inside of each of these are all different projects. And so I can open up this one and kind of give you a view of like, these are all the files. And then typically we'll create like a little document that helps someone that's just new to the project and they want to understand, how is it that I get started with this? What does this project actually do? It's kind of neat that you'll actually even see, if I go back to the other screen, you'll see what technologies and languages are being used in each of these projects without going into them. So GitHub does a great job of saying, okay, the top languages in our repositories across all of our 147 repositories is JavaScript. We've got some C#, we got HTML, TypeScript. Jupyter is Python, Jupyter Notebooks. So these are all the people that have access to these in our organization. And when you jump into one, you basically say, oh, okay, this is the code. You can kind of navigate through the file structure. Doesn't look like there's much in that folder, but if I go into this folder, I see, oh, there's all these different files. And these files, they could have code that looks something like this. So these are settings that sort of describe how we would be able to access this particular server, who has access to it, what rules and roles that they have. So this allows someone to basically get some information. And if you're an admin, you have access, but everybody else just gets denied if they make a request to this particular location on the server. The code looks a little bit more like this. So inside of here, you'll see that there's some slightly different colors. It may not be super obvious on your screen, but the colors help us to know that we've written correct syntax. The language is like, it's got to be very precise. You can't make spelling mistakes when you're a programmer. Everything has to be spelled exactly the right way. All of the characters matter. And so the colors help us to know when it's properly formatted, and it helps us to kind of be able to make it readable and understand, like, okay, this is a keyword and this might be a variable, right? And so as I'm looking through very quickly, I can see the colors and it helps me, read the code itself. As a software engineer, you probably spend more than half of your day reading code, looking at other people's code. And so it's really critical that you have some ability to be able to make sense of it rapidly, right? If every time I was looking at someone's code, it was hard for me to understand, I'd spend much more of my time just like asking questions and trying to get to the point. Once we're at the point where we're going to go in and make edits, then we use an editor. So this is an online editor. Let me see if I can quickly get in here. And it actually is in the cloud. So this is not on my local computer, which is why today, you can even have a very low powered Chromebook and be able to connect virtually with what I just showed you, where the code's stored. And you can bring up an editor, but the editor is running on a machine in the cloud. So it's not using the resources of my little computer or my laptop or my iPad. It's actually using the resources of a big computer that's somewhere in a big data center. So once this is kind of loaded, it's taking a little while because it has to actually spin up the resources. I basically see all of those same files that are being versioned and controlled somewhere else. But as you'll see now, the coloring is slightly different. And this is inside of an editor where I could actually go in and make changes to this code. And this is a comment. So this won't run in the system, but it's sort of a message and note that I can leave to other developers to let them know this is why we wrote this portion of the code. And then I could edit it and I could run it and I could see, does this program do what I expected to do down here at the command line? So there's a lot of that kind of throws people off a little bit early on when they're learning to be a software engineer. You don't always get the feedback. You don't always get to see and click on things, but instead sometimes you have to know what to type, and then you have to know how to interpret the responses that the machine gives back to you. So for a lot of folks, that's sort of that makes them a little apprehensive. But once you understand what you're doing, which is basically just giving it a set of instructions and then having it run those instructions and then give you feedback, you kind of get over the lack of being able to visually see everything and instead focus a lot on words. If that makes sense. So this is what it means to like edit and read code. I have to go in here. I have to understand what each of these lines of code are doing, and they're all numbered to make it easy for me to communicate when I'm talking to someone. Hey, go into line 6 and make sure that you add this keyword, right? Or on line 15 through 26, there's a function, and that function is broken. So we use these, line numbers to help people navigate when we're communicating together about how we should change this file. And then we use systems to manage, like, okay, if I made this change, I can sort of check it in to the repository so other people can see the change I made and compare it to the existing code and see if it breaks anything. Is that a good high level overview, Mr.
Yeah, I
Steinbeck?
mean, this is, you know, one thing is kind of a lot of people, if they don't understand what software development is about, I mean, this is the environment. There are a lot of different ones, but this is if we're talking about writing and reading code, this is what we're talking about.
Yep.
This is what it looks like. And so behind every web page, behind every application, behind everything that's on your phone, you're going to find these files that have basically the code in it that tells the computer what to do and when to do it, right?
Yeah,
and
take a page
behind Google even, right?
Yeah, like this page right here. There's actually behind the scenes, if you right click on your browser and then you click inspect, this is what I meant by being able to, freaking out a little bit there, but this is what I meant by being able to code right in your browser. So this is the actual code that's being sent from the server, and then your browser takes all this, they call it HTML markup. It takes all this HTML markup and it just creates this visual representation of it on the screen that you typically interact with. But behind the scenes, and this isn't a special tool that only I have, you can do this on any web page that you have in the Chrome browser. It looks a little bit different in Firefox browser or Internet Explorer, but all of them have this functionality where you can just right click and then inspect the code, or you can just view the page source, which again is just, it's going to just put a bunch of this code on the screen. And now instead of me seeing the web page the way I normally see it, this is the behind the scenes that just gets translated into what you just saw a moment ago, which is, you know, the normal Google web page, which is this right here. So this code right here is what generates this part that you see. And some of it's kind of hidden because we're loading some of this as code. We're loading it right here in this JavaScript file. So it starts with just a little bit of styling and a little bit, and it goes into this file right here, and then it creates everything else that makes me able to actually click in here and see this drop down with some options in it, and to see these apps and be able to interact with them by clicking on them, or click this microphone and be able to talk. All of that is in that one JavaScript file. So again, JavaScript is the language that adds all the functionality to the page. And then we got all the styling. You can come in here. So what I love doing is you can come in and you can just start changing some of these things. And you can say, well, what happens if I didn't align the content in the center? I just turn it off. Oh, wow. Look at that. Right. And then I could just turn it back on by checking the box again and saying, oh, so align item center. It must center everything on the page. You can kind of hack at it and you can say, well, what does display flex do? Oh, wow. Made everything disappear. So flex must have something to do with the layout of these things on the page. And then you can adjust the heights and you can change the positions of things, and you can go in and you change the size of fonts. And so by going in and just making adjustments, it's kind of cool to see in real time how you can change, you know, a popular page that you're working with. Again, all of these options are editable. You can go and you can actually add your own. So if you know what to write in here, you can write code to actually change this page. It's not being changed for anybody else. It's just being changed for you in your personal browser. That's the cool thing about web development, is everything's actually in your browser. So this has been sent by Google to my browser. So now I can actually edit it. I can change it. It doesn't go anywhere else. It doesn't change for anybody else. It does change for my version that I now have in my browser.
Okay, unfortunately, we're going to run out of time here in a minute, but I want to make sure the students who are in the session here with us kind of understand a little bit about what the environment is like to be a software developer. There's a lot of different aspects to the job. I've done this in the past myself, and I still do this on the side at times as well. So I'm very familiar. In case you want to talk to me, I'll get you in touch with Mike Roberts as well. The one thing to understand is that it's a great occupation, right? You can make a really good living at it, and you know, it's not a skill set or an occupation that's going to go away anytime soon. There are just more and more demand for this out there. And again, Mike went over the different routes you can take, self-taught, which is not as common, but you still have to do anyway. There's going to college and getting a CS degree. And then now we have a great program here with Mr. Roberts in terms of an apprenticeship program, which is a big deal because you want to avoid student loan debt at all costs if you can. and get out there and actually get your hands dirty, actually working on stuff. That's far more important than anything, is getting that experience under your belt. All right, we have to close down now because I do have to start up another session, but I want to thank everybody for coming today. And hopefully we can do this again in the future and maybe take a little bit more time and get a bit more in depth. But if you have any questions on careers in software development or even in tech, email those to me over at the Career Center over on my Canvas page. And then if you want to contact Mr. Roberts, you certainly can ping me for that, and I'll get you in touch with him as well. All right, guys, I got to go, but thank you so much for being here today. I do appreciate it, and hopefully this helps to give you some insight into the career of being a software developer.
Awesome.
Thank you.
Thanks, everybody.
Thanks, everybody. Take care.